Uh, we're going to talk about the equations of motion in this video. Now, before we do that, we need to know about the acceleration due to gravity. Now, we know that the gravity, the force of gravity here on Earth, it accelerates all objects at a rate of 10 meters per second squared, or 9.8 meters per second squared to be precise. We can work that out by experiments. We can do experiments to find that out. And we know that the gravity accelerates all objects, whether they're heavy or light, at the same rate of 10 meters per second every second. The speed changes at 10 meters per second every second. Now, this was proved by Galileo in his famous experiment from the Leaning Tower of Pisa. He threw stones of different weights and he found that they reached the ground at the same time. But then you might say that can't be possible, because if we drop a stone and a feather, the stone goes down very, very quickly. The feathers just gently flutters down. Well, that is because of the air resistance. The feather has got a much greater air resistance. That's why it moves slowly. Now, if you threw both the stone and the feather in the vacuum of on the moon, where there's a vacuum, there's no air resistance, they will both reach the ground at the same time. Now we're going to come to the equations of motion. In the last video, we talked about the acceleration. We defined acceleration as A is equal to V minus U divided by T. Now we're going to use these standard symbols. S stands for distance, U for the initial velocity, V is the final velocity, A is the acceleration, and T is time. These are the standard symbols, okay, which are used in these equations. So first of all, if we take T to the other side and multiply A times T equals V minus U, and rewrite the equation the other way, we can write V is equal to U plus AT. Okay, this gives us our first equation of motion. Now, the final velocity is equal to the initial velocity plus acceleration times time. Now, the second equation involves the distance. The distance traveled is velocity times time. But if the object is accelerating, its velocity is changing from U to V, then we take the average velocity, which is U plus V over 2, divided by 2. That gives you the average times by T. So the second equation is S is equal to U plus V divided by 2. This is the average velocity multiplied by the time. This gives us the second equation. Now we can get the third equation from this. If we rearrange for T here, T will be equal to V minus U divided by A, and substitute into this one. You don't really need to know the proof, and it's quite simple. You can actually prove this. For the GCSE, you're not required to know how to prove these equations. So I can just show you where it comes from, and we will write it down. We say that S, so we substitute for T, so that gives you S is equal to UT plus a half AT squared. Okay, this is the third equation. Second equation, I'll just this is number 3. And the fourth equation we can get by substituting for t into this one is s equals u plus v over 2, and t is v minus u over a. Okay, if you do that, you get the equation v squared equals u squared plus 2as. Okay, so these are the four equations of motion which we are going to use in order to solve problems. Now, as I said, you don't really need to know how to prove these. Okay, as long as you know how to use them. And we're going to use these by doing examples. Right, let's rub this out. Because I'm going to use these equations to solve the problems, I'm going to write these over here. V is equal to U plus AT. S is equal to U plus V divided by 2 times by T. And S is equal to UT plus a half AT squared. And the fourth one is V squared equals U squared plus 2AS. Okay, we're going to keep these here because we're going to refer to these later on. I can just write a number. This is number 1, that's 2, that's 3, and this one is 4. Okay, now let's do an example. Example number 1 is a car starts from rest. And accelerate at 2 meters per second for 10 seconds. We calculate A, final velocity, B, distance traveled, okay. Now, once you have a problem like this, it's best if you write down all the information that we are given and then see what we are given and what we need to find. Now, in order to remember all the symbols, if you remember the word SUVAT, S, U, V, A, and T. S is the distance, U is the initial velocity, V is the final velocity, A is the acceleration, T is the time. SUVAT, S-U-V-A-T, SUVAT. If you remember SUVAT, you can remember all the things that you need to know. Now, in this case, we need to find the distance traveled, so we don't know the distance and we don't know the final velocity. But we know the initial velocity. A car starts from rest. Now, rest means its initial velocity u is equal to 0, right? So its initial velocity is 0 because it's starting from rest. So u is equal to 0. Do we know the final velocity? No. Acceleration. It accelerates at a rate of 2 meters per second square. Acceleration equals 2 meters per second square. And the time it takes is 10 seconds. Okay, so we know these things and we need to find the other two. So first of all, I want to find the final velocity. So we want an equation that connects u, v, a, and t. The initial velocity, final velocity, acceleration, and time. And this equation is number 1. V, u, a, and t. Okay, so using the equation 1, v is equal to u plus, this is part 1, u plus a times t. Now, final velocity equals initial velocity plus acceleration times time. Now, initial velocity is 0. So this is 0. Acceleration is 2 meters per second. So it's 2 times time is 10 seconds. 2 times 10 is 20 meters per second. So the answer is 20 meters per second. Its velocity, final velocity will be 20 meters per second if it keeps on accelerating at the same rate for 10 seconds. And part B, to find the total distance traveled. Now, I could use this equation, u plus v divided by 2 times t. But I worked out v, and I might have made a mistake. Now, if I use that in the next part as well, then I could get the next part wrong as well. So it's best to avoid that and see which other equation we can use for S. Now, S, without using V, S is U, A, and T. S, U, A, and T is equation number 3. So we can use S is equal to UT plus a half AT squared. U is initial velocity, which is 0. 0 times, the time is 10, plus a half times the acceleration, which is 2, times t squared, which is 10 squared. That gives you the distance. So half of 2 and 2 will cancel out. 10 squared is 100. 0 times 10 is 0. Okay, so that comes to 0. So the final answer is 10 squared, which is 100 meters. So it travels a distance of 100 meters in 10 seconds if it keeps on accelerating at that rate. Right, we'll do one more example which involves gravity, and that's why we talked about gravity. Let's rub this out. I'm going to leave the S, U, V, and T, SUVAT, there, okay, because we're going to use that in the next. Now, what I've done is, I've written this on a piece of paper instead of having to write it on there. So we'll write this, I'll hang it up there. I hope you can see it fairly clearly. Yeah, I think it's visible, so you can see it. It says a ball is thrown vertically upwards at 20 meters per second. Calculate how high does it go, and B, the time taken to reach this height, the maximum height, and how long does it take to return. So we are here on the ground, and you throw a ball at 20 meters per second. 20 meters per second. Now, this is the initial velocity, okay? We give it an initial velocity, u. Now, u is 20 meters per second. Now, what happens? Now, remember, when we throw something high, it starts slowing down until it reaches a maximum height, and then it starts to come down. So it's going to go right up there, up to a maximum height, and then it will come down again. Now, when it reaches there, well, what is the velocity when it reaches at the top? Because it must stop there and then come down. So its final velocity, v is equal to 0. Okay, so the initial velocity that we've given it is 20 meters per second. Its final velocity is 0. And what about the acceleration? Now remember, acceleration is due to gravity. Now when the ball is moving upwards, the gravity is decelerating it, is slowing it down. So the acceleration due to gravity is 9.8 or 10. So in this case, it's a deceleration of, which is minus 10 meters per second squared. And the time, we don't know the time, and we don't know the distance. So first of all, how high does it go? Now we need to find the maximum height. Okay, so we know u, we know v, and we know a, and we want to find s. Now, which formula can we use to find the distance s? So the easiest one to use will be s equals u plus v divided by 2, because we know both u and v and the time. No, we don't know the time, sorry. We can't use that. We have to use how high does it go? We have to use u, v, a, and s. So for the first one, I have to use this one. V squared equals u squared plus 2as. V squared equals u squared plus 2as. Now, the final velocity is 0. The initial velocity is 20, which means 20 squared plus 2 times the acceleration due to gravity, which is minus 10, negative 10, times by s. Right. Now, if we, right, 20 squared is 400. Now, 2 times minus 10 is minus 20, s equals 0. Now, if you take the 20s to this side, that becomes plus 20s. 20s equals 400. So s is going to be 400 divided by 20. Cancel the zeros. 40 divided by 2 is 20 meters. So it reaches a height of 20 meters. Okay, now part B, this is part A. Now part B is the time taken to reach this height. So we need to find the time t. We know A, we know V, we know U. So we can just we try to avoid using S, because we've calculated that. So something that connects U, V, A, and T. And that's the first equation. V equals U plus AT. V equals U plus A times T. Now the final velocity is 0. The initial velocity was 20, plus the acceleration is minus 10, negative 10 times t. Again, minus 10 times t is minus 10t. Okay, bring it on this side. That will become 10t equals 20. So t is equal to 20 divided by 10, which is 2 seconds. So the time is 2 seconds. For it to go up there, it takes 2 seconds. Now, how long does it take to return? Now, part C, if it takes 2 seconds to go up, then it will take exactly the same time to return. So the time taken to return, C is, the answer is also 2 seconds. Same time. Okay, and if they ask you for the total time of flight, how long was it in the air? Like it goes 2 seconds up and 2 seconds down. So altogether 4 seconds, it stays in the air. So what you need to do is you need to practice lots of questions, okay, using these formulas for your GCSE.